what's going on here, Mr. Hmwk?
Well, I found something to try in class this year, and that's called triops. From the age of the dinosaurs, watch the triops hatch from their eggs and become little fishy creatures. Takes 24 to 72 hours. They're alive. Woo! So, but I just read that I have to add limestone. I have to add limestone for an hour, or no, 24 hours, I guess. So I guess it'll be on the next video, and then we'll add the triops, and then we'll see them hatch in the next video after that. Woo! So thanks for watching. So I thought I was gonna just show you and pour the little sand creature eggs in there, but we'll do it. We'll have to do the limestone first. 24 hours. Wayo. Limestone first. Make sure they hatch right. Right? Make sure that they hatch right. Cool. So thanks for watching. We're doing 12, here it is, 12.1. So 12.1, let's go. So don't forget for the final exam, there's lots of review to do still. Get you ready for the final exam. How do we undo the cube root? We power 3 both sides. So that's going to get rid of the cube root. We're left with x over 3. Pause me. Try it on your own. Negative 2 times negative 2 is negative 4. Times negative 2 is negative 8. And then we'll minus 5 to the other side. So we get negative 13. And then we're going to go ahead and times by 3 over to the other side. Nice. Negative 13 times 3 is 26. 39. X equals negative 39. Wayo. So we'll check that answer key there. Yep, negative 39. Let's go. Oh, I also got something else to show you, actually. For May the 4th be with you. Have you seen it? Did I show it in class? Whoa, 10,000 Legos. It's a, gotta come to class to see it better. So it's a Skywalker and Yoda. 10,000 Legos. So come to class. Did you see it? Did you see it? It's kind of hard to see from so close. So make sure you come to class so you can see that better. Right? Make sure you come to class to see that better. There we go. Okay, next one. Try it on your own. Try it on your own. So we're going to have to minus 7 to the other side first. We get 4. And then, wow, how do you undo 2/3? Do you remember that for the final exam? So let's see. So the third is the cube root. And the x minus 5 is what's being squared. So that's the power. And that's the root. So then we're going to have to undo the root probably first. You can go either way, either order, but let's go ahead and undo the power of 3 first. So we're going to third power that. And that's going to get rid of the root. But if you do to one side, you have to do to the other side. 4 times 4, 16 times 4 is 64. And then, how do we undo the squared now? Remember how to undo the squared? That's right, square root it. So then when you square root it, you get x minus 5 is equal to, and see here, you get square root of 64 is 8. There we go. And so then we're going to go ahead and add 5 to the other side. And now we get x equals 13 as our answer. So series or sequences, we haven't really done those yet. You can kind of get the idea. So find the sum of the following sequence. So 256 looks like it's, see, that's 8 times 8. Is that 8 times 8? 8 squared. 4 squared, 2 squared. Can you see the pattern? Can you see the pattern? 16 squared. So the next one is just going to be, so half of 16 is 8, half of 8 is 4, half of 4 is 2, half of 2 is 1. Aha! So it's really just a 1 that we're adding in there. Find the sum of the following sequence. And so that's just a 1. And so if we add all those up, basically, as I found sequence, it's going to be 256 plus 64 plus 16 plus 4 plus 1. Yeah, 341 is the sum. The sum is 341. But don't worry, I won't put that on canvas, probably not if we didn't learn it this year. Find the next three terms in the sequence. So what's the difference there? What are you thinking there? Is that 16 and 9? So is that 7? We're adding 7 again goes from -9 to -2. So we're adding 7 because that's going down, going down, going down. Yep, adding 7 again. So the next one should be adding 7, which is 12. And then we add 7 again, which is 19. And then we add 7 again, which is 26. So 12, 19, 26 is the next three terms. See, you could have done sequence. You know what you're doing. Okay, here we go. So piecewise functions. Let's go. So you try number 6 on your own. Way-o. I'll help you with one of them. I'll help you with f of 0. So where is 0? Where is 0? 0 is between -2 and 2. So we plug it into this equation. So then we get, what do we get? We get -3/4 times 0, which just goes away. Boom. And so we're just left with 5/2 as our answer. Or 2.5 if you're plugging it in the canvas. And then where's 1? Is 1 less than -2? No. 1 is greater than 2? No. 1's still in the middle. So 1's still in the middle. And so that's going to be what? -3/4 times 1 is 3/4 plus 5/2. But that's actually -3/4 times 1 is just -3/4 plus 5/2. And you have to times it by 2 to the top and bottom. So that's actually 5 times 2 is 10/4. There we go. 7/4. So you try this one. Try plugging in -2, which is less than no. Wow, they're all in the middle? That's crazy. So -2 is less than or equal to -2. So you also plug in that one. You give that one a try. -3/4, -2 plus 5/2. And then graph it. And then graph the parabola. So you're going to graph the parabola. You're going to graph the line with the negative slope. And then you're going to graph the up and to the right, up and to the right. Okay, we'll do the easy one because it's odd. Aha! You behind the screen, try it on your own first. So number 7 is -2. So this is saying y equals, just so you know. So technically, this is going to be y equals -2, and y equals x to the 3rd power is what's really happening here. And then all numbers less than -1, like -2, -3, -4, etc. And then this is x to the 3rd power greater than or equal to -1. So that's including -1, 0, 1, 2, 3, etc. Cool. So we plug a 7 in. 7 is greater or equal to -1. So that means we're going to put a 7 to the 3rd power. And 7 times 7 is 49. And then 7 times 49 is 343. So that is a nice answer, but not going to help us on our graph. What about, let's see, what about -1? Well, where would -1 go? So -1 has to be, can't be less, -1 is not less than -1, so that doesn't work. But equal to works. Yep, -1 is equal to, that's basically an equal to. And -1 is equal to -1. So now we're going to plug it into this equation. So it's going to be -1 to the 3rd power. -1 is a positive 1 times -1 is a -1. H of -3. 3 is definitely less than -1. So that means the answer is just -2. Because it's just a line of the equation. Let's graph that line. Y equals -2. So -2 is down here. This is another way to do it that I might not have shown in class, where you just graph both of them, and then you do the boundaries, the cutoff, basically. So where's our cutoff? Our cutoff is that our cutoff for -2 is that x has to be less than -1. So where's -1? There's -1. It has to be less than, and there's it's not. It's going to be an open hole, basically, right? Because the only time you do a closed hole is if it's an equal to. Less than is an open hole. So we have an open hole at -1, And then everything to the right, we're going to erase. And that's our line there, y equals -2 to the left, right? For these values, right? Going to the left, -2, -3, -4. Cool. So then the next one is x to the third power. And so that's going to be -1 onward. And there is, well, flex is starting. So there is a equal to there, which means closed hole. So equal to means closed hole. So there's an equal to, and since there's an equal to, so 3 is greater than or equal to -1, so x is greater than or equal to -1. So that's an equal to, and so that means closed hole. And then the other one is x is less than -1, and so that one means an open hole. That one means an open hole. So now we're going to do a closed hole now. Closed hole, so that's going to be greater than -1, so that's going to go in this direction, -1 onwards, and it's x to the third power. So let's just go ahead and do y equals x to the third power, and for numbers greater than or equal to -1. So you do an xy chart, and you put in greater than or equal to. So we put -1, we put 0, we put 1, we put 2. So then we already figured out this one, that was -1 was a -1. If you put a 0 to the third power, that's just 0. 1 to the third power is just 1. 2 to the third power is actually 8. And so that's going to be a positive 8 there for our xy table. So we're going to go -1, -1, which is down here at -1, -1, then 0, 0, then over 1, up 1, and then over 2, up 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go up like this, x cubed, doing x cubed, all the way up there like that. Thanks for being here, you guys. Help me in 2 seconds, just finishing a video real quick. Okay, beautiful. So that's our graph. I'll go ahead and show it to you in red really quick. Come on in, just doing a quick video. Come on in, come on in. Just doing that piecewise video, new lesson. Now, that looks like it's connected, but it actually shouldn't be. So that's where the next graph starts, up there. So open hole here, then it jumps up to -1, -1, this guy, which is right here. And then we have 0, 0 next. Right, curve it, and then all the way to infinity. Cool. So the other one, this is a crazy one. So this has a parabola. So it looks like we're at, come on in guys, just make a video, almost done. Come on in, just make a video right now. So it looks like we have less than -3, so 1, 2, 3. So I'm going to draw a dashed line, kind of, this is where and -3 is where the boundary is going to kind of change. Not an asymptote, but a boundary. Then -3 to 1 is where it's also going to change. And then greater than 1. And so this is y equals -2. From -3 to 1, both closed hole. So we have at -2 now. Come on in, just doing a video at -2. We have a closed hole, right? So that's basically -3, -2 for the y value, as well as 1, -2. There's -2 everywhere. So that's just a straight line. So that one's done, that one's done. Then we also have, let's distribute this through. This is actually a line. Come on in, just make a quick video, I'm almost done. So that's -9 minus 2 is -11. So come on in, just make it a video, come on in, just make it a quick video, almost done. So then we have a y-intercept way down here, -11, that's crazy sauce. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we're going to go a slope of -3. So that's going to be down 3 over 1. So up 3, back 1, up 3, 1, 2, 3, back 1, 1, 2, 3, back 1. So I'm thinking at 3 there's an open hole and it's also has a closed hole. Let's see if that's right. So we plug a -3 in there, we get 0 and 0, -2. So that's not right, but I'll finish this video after for lunch. So I'm going to go ahead and pause this because everybody's in here. Woo! Thanks for being here. And we're back. That was super crazy awesome. So many students came to Flex to finish their test. Woo! Okay, so we have y equals 2 done, check. So now we still have a parabola at greater than 1. So we should have some kind of parabola here. I don't know if it's right there or if it's up here or down here. We got a parabola going on to the right. And so here's our parabola. So our parabola basically is y equals x minus 2 all squared. So that means from 0, 0, we're going to go what? What does that mean? Not left 2, opposite what you think. So it's going to be right 2. So from 0, 0, we're going to go right 2. And then, do you remember how parabola works? Do you remember how parabola works? Remember the parent function of parabola? Remember? So it goes like 0 squared is 0, 1 squared is 1, and then 2 squared is 4. 1 squared is 1, 0 squared is 0. Yeah. So from our right shift 2, let's see, so now we're going to go over 1, up 1, because 1 squared is 1, and then over 2, and then up 4. 2 squared is 4. And then going to the left, we're going to go left 1, up 1. However, it's going to be on the boundary, so it could be an open hole or a closed hole. Let's see. So it's not equal to, it's just that way. So that means open hole. Right? Without the equal to means open hole. So that means we will have an open hole right there. And then we go up and to the right. Now, what about going to the left? What do we have? Oh yeah, we're trying to do graphing of a line. So I'm going to do y equals negative 3x minus 11. Probably just going to do an xy table, honestly, to help us there with that, because it doesn't have a squared there. Is it supposed to be a squared? I don't see a squared. So I think it's just a line. I think it's just a line, right? I think it's just a line. So then, let's see here. So then, because I just distributed that through, I think it's supposed to be square, but I think they messed up on this number 9 problem. Well, because I just distributed stuff through. I don't see it too. I don't see a square there. Okay. I think there's supposed to be a square there. Whatever. Okay, so xy table. And now we're choosing values of negative 3 and negative 4, negative 5, basically. And so we plug in negative 3 in there. That's negative 3 times, plug in the negative 3. Negative 3 times negative 3 is 9. And 9 minus 11 is 2. So at negative 3, wait, it's an open hole, open hole. So that's at negative 3, it's going to be up 2, so negative 3 up 2. Beautiful. And then we plug a negative 4 in. So negative 3 times negative 4 is 12, minus 11 is 1. So then at negative 4, it's going to be a 1. And then put a negative 5 in. Negative 5. Let's see here, negative 5 times negative 3 is negative 15. 15 minus 11. 15 minus 11 is 4. This just seems kind of weird how this is working. 9 minus 11 is 2. I don't know, this seems kind of weird. I feel like it's supposed to be a parabola. Anyways. Okay, so that's going to be negative 1, 2, 3, 4, 5. Up 1, 2, 3, 4. Yeah, let's try the negative 4 again. Negative 3x, negative 9, and then minus 2. Oh, I see, and then yep, that's how I got negative 11. Interesting. So that's going to be positive 12, minus 11 is 1, and so that would be, I feel like it should be a 3. I feel like this should be going down as your slope. This is so weird. What's going on with this guy? For less than negative 3, right? Probably supposed to be a square there. I think they messed up. I don't know. Lame. Okay, so again, I distributed through, and we got negative 3x, negative 9, negative 11. So we plug in, let's try plugging in negative 3 again. Negative 3 times negative 3 is positive 9. 9 minus 11 is 2. So negative 3, 2. Let's try plugging in 0. Yeah, negative 0. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it should be way down there. The slope should actually be down 3 over 1, honestly. So that's why I'm confused of what's going on here. So the slope should be negative 3. So that's down 3 over 1, down 3 over 1, down 3 over 1. And so that's why I was going up 3, back 1, up 3, back 1, up 1, 2, 3, back 1. So I'm pretty sure the line should just be here. So I'm not sure what's going on with this one, but it's not on canvas. We'll kind of leave it for now, because I really feel like there's supposed to be a square there, but I think they messed up. So we'll move on. Don't worry about that one. Okay, so now we're jumping down to 11. We're going to come up with the equation. So we're going to go ahead and post some values in there. Post some values in there. Actually, you know what? We need to go to our next video. Well, I'll just give you an example. So we'll go to our next video. So g of x equals negative 3. So you go to negative 3. Here's negative 3. And so we're either there's a hole there, or there's actually a dot there. And since there's a dot there, not just a hole, we are going to say that there is a y value. And that output is 3. So at negative 3, we go up 3, right? At negative 3, we go up 3. And then at g of 0 is just 0. G of 0 is 0. And then g of 11, you have no clue. You need the equation to be able to do g of x equals 11. That's going to be 7, 8, 9, 10, 11. That's way over there. So we're going to have to come up with that equation first. And so we'll see you on the next video. Thanks for watching. Bye for now.